New Thinking Aloud is presented by the California Institute for Human Science, a fully accredited university offering distant learning graduate degrees that focus on mind, body, and spirit. The topics that we cover here. We are particularly excited to announce new degrees emphasizing parapsychology and the paranormal. Visit their website at cihs.edu.
Thinking Aloud. Conversations on the leading edge of knowledge and discovery with psychologist Jeffrey Mishlove.
Hello, I'm Jeffrey Mishlove. Today we will be exploring the unification of mind and matter. With me is Nobel Laureate physicist Brian Josephson. He is the director of the Mind-Matter Unification Project in the Theory of Condensed Matter Research Group at Cambridge University in the United Kingdom. Professor Josephson won the Nobel Prize in Physics in 1973 for predicting unexpected supercurrent movement or hidden oscillation through a tunnel barrier. He was 33 years old when he received the prize and only 22 when he published the original insight. The Josephson junction led to the development of superconducting quantum interference devices known as squid magnetometers, which are capable of making highly sensitive magnetic field measurements. Josephson's research since then has revolved around intelligent processes in nature as they relate to foundational physics. He is the co-editor of the anthology Consciousness and the Physical World. This interview was conducted via the internet, so now I will switch over to that channel. Welcome, Brian. It's a pleasure to be with you. I've known you for many years, but this is really our first time together doing an interview, so I'm very grateful that you're able to take the time to be with me today. And you have focused on the unification of mind and matter, and you've noticed, for starters, that physics is incomplete if it doesn't have a picture of mind, because mind is obviously a very integral part of reality.
Yes, except the standard position is just that it's the brain, and so there's nothing special about it. That's just a thing for a neuroscientist to worry about. But there's difficulty about observation in quantum mechanics, and people are sort of arguing about what's really going on there. And a number of people have said, well, here the observer and mind and so on fit in. So it'd be good to add that into physics.
Yeah, the founders of quantum mechanics all seem to have a very deep interest in the nature of consciousness, and they were also to some degree students of Eastern mysticism.
Yes, some of them, yes. So I guess people rather went off that. They became more materialistic, perhaps.
Mm-hmm. It's as if the founders, well, I guess maybe a better way to say it is if physics has moved in a different direction since those days. Yeah,
so I guess it has been an issue. Well, the non-locality has been a bigger issue, I think. Mm-hmm. But then observation plays an important part. One person observes and someone in a distance gets a correlated result. And John Bell showed that it's difficult to explain that. They are too much connected, the two systems, to have an ordinary explanation.
Mm-hmm. Which is essentially the definition of non-locality.
Yeah.
Mm-hmm. Particles seem to be able to relate to each other in ways that wouldn't normally be allowed because of the limitation of the speed of light.
Yes, and the entanglement seems to be the issue. This is the fundamental thing that there's a strange kind of connection, yes.
Mm-hmm. But I gather that in your work, you're really looking at properties of matter itself, and I guess entanglement or non-locality might be one such property, but there are other properties of matter that suggest maybe not consciousness per se, but at least the capacity to engage in activity which appears to be mental in nature.
Well, John Wheeler was the person who talked about that. He talked about observation having interesting effects, and that he wrote in an article that maybe everything comes from observation, or the difference between subject and object. Mm-hmm. And he used the word fabrication of form. Mm-hmm. You could create a form by the application of the observer. I don't think he used the word mind, and he definitely didn't like to talk about consciousness. Well, I don't like to talk about consciousness either, because I'm not too sure how to handle it.
Mm-hmm. Well, yeah, Wheeler was actually hostile to my field of interest, parapsychology, which I know is also an interest of yours as well.
Yeah.
But you look at the whole field of semiotics and biosemiotics, which is really a philosophy that goes back to the 19th century with Peirce.
Yes,
the notion of signs.
I think what really got me into this was I suddenly thought back to something I'd read, I think, in the 1970s, Winograd's computer simulation of language understanding. This is extremely mysterious, how language works, and if we can understand that, then it's going to be a great advance. And then I thought of looking at Winograd's computer simulation, and what he's doing is putting a lot of bits together. He guessed all the things going on in language and what they're all about, and he simulated them in a computer program, and lo and behold, it could understand complicated sentences and work quite reasonably. That seems to be a great clue then, that you can put pieces together and you get advanced forms of mind.
Mm-hmm.
He didn't actually study acquisition, but you can add that in. You say that you have a lot of issues you have to sort out, ways of dealing with these particular issues. And so we have potential theory as to how mind comes into existence. Mm-hmm. That also would include manipulating matter, because we manipulate matter with our minds.
All biological systems seem to have that capacity, but you've even gone further than just biological systems and talked about, for example, the field of cymatics and how water itself actually seems to be able to respond in an intelligent way to vibrations from acoustic waves.
Yes, that's something that came in rather unexpectedly. Well, I'd been interested in memory of water because I was actually connected with Jacques Benveniste from the very beginning, before he submitted to his paper, which the editor of Nature didn't like. And then so I kept up with him, and so he found apparently you don't have to use high dilution of an active chemical. You could pick up vibrations from it and apply those vibrations to water. You would even send it over the internet and somebody else would get the effects. Mm-hmm. That proved a bit difficult to reproduce, but Luc Montagnier has now taken this up and being attacked for this controversial thing.
So you're really also bringing up the whole subject of homeopathy, when you mention Benveniste's work.
Yes. Well, he taught more of memory of water, but he got into it because there was someone interested in homeopathy in his group who persuaded him to try it. Mm-hmm. So he said very little about homeopathy, but of course this. Well, I got into it because I can see that people who ought to know better are making objections which are invalid. Mm-hmm. I say you can easily disprove the idea of memory of water by any one of a number of easy to understand invalid arguments. So people understand these arguments, think, oh, this disproves it, but it doesn't. For example, you don't necessarily have to have any of the original substance dissolved in water after you diluted it. There may be some structure or activity left behind.
Mm-hmm. In other words, there needn't even be a single molecule of the original, let's say, homeopathic remedy in the water, but after the molecule is gone, some sort of structural element, almost non-physical, is still left. Well,
needn't be non-physical. I mean, it'd just be an interesting structure. Interesting example is the quasi-crystal, where your crystal produces a diffraction pattern suggesting it's got fivefold symmetry, which a crystal shouldn't. And really, if you looked at it, you would see it's disordered, but it happens to be some relationships which are enough to produce this. So it shows you can have a rather hard to see structure which can do things.
I'm wondering if when you're talking about a crystalline structure like that that's not supposed to be there, is it hyperdimensional? Is that what you're getting at?
Well, it's interesting that it's been shown that the quasi-crystal you can get by having some like six-dimensional crystal and putting a slice across it. There's this technique, but I think that's not. I think that's a bit of a distraction. It's just that if you want the atoms to arrange themselves to be, say, minimum energy or minimum free energy, and just this act of minimization happens to break the symmetry, so not all directions are the same. So it's connected with symmetry breaking.
Mm-hmm.
And there's a parallel there actually with how the mind or how the brain works, because there you have a complicated system and you put it in a certain environment and it happens then to end up doing things. So there's a bit of similarity there. You let a system settle down and it then can do interesting things.
Mm-hmm.
And the same with cymatics as well.
Yeah. In cymatics, you've written about how when the pitch or the frequency, the volume of the acoustical signal changes, the patterns that show up, and I'm going to show these on the video so our viewers can actually see it. The pattern changes. It gets chaotic for just a moment, and then all of a sudden out comes a new pattern, crystalline looking, and you suggest that the water itself seems to be searching for a stable pattern.
That's right. And someone, I guess we both know, Rufus Sheldrake, has actually examined this in detail and shown how it changes as the frequency changes. So, yes, it's interesting, these patterns, but it is presumably just a question of finding some that's roughly stable. Or at least there's no overall change with time. It settles down anyway.
Mm-hmm. Well, so this would be an example of something as simple as water molecules showing an apparent intelligent activity. And I guess that's what you're getting at. And in fact, I think you go even a little deeper than that, because in the work you've done with Alyssa Yardley looking at geometric patterns, you're suggesting that meaning is even embedded in geometry. Things like circles and lines and triangles are laden with meaning.
She's talking about something very subtle, like these other things I'm working, and that's why it's not obvious what she means. But one thing which is probably correct is if you have something circling away, then it may create these structures. It's really quite similar to what happens in cymatics. So the key idea is you have structures which are consistent with each other. That's a theme you get in semiotics, actually, but I guess she's particularly emphasizing it. For example, language system and the things you do with that system, these interact with each other and they come to some kind of equilibrium.
Mm-hmm.
So there's really some very interesting things happening, but it's all rather mysterious. I think we have to take the experimental attitude and say we can't necessarily prove that these things will happen, but we can make models and do experiments which show that these intriguing things happen, and that's just not in ordinary physics.
Yeah. You also, many years ago, in fact, I was there, I think 1994 in Tucson, Arizona, you presented a paper on music and talked about the transcendental nature of music and suggested that there might well be a Platonic realm that's related both to the physical realm and to the realm of consciousness that connects them, a realm of forms, and that this realm is what gives music certain unique properties that, as you said earlier, are quite subtle and hard to describe, but people who listen to music seem to be able to recognize.
Yes, I think John Stuart Reid claiming somewhere that good music makes nice patterns.
Mm-hmm.
Well, the point there was I was actually collaborating with a colleague who's in musicology, and we I think we both felt that the usual psychology of music is insufficient. You talk about predictability and unpredictability, and that doesn't really seem to capture the essence. So one point my colleague made is that musical theme is something which you can use again in a completely different bit of music. So if these themes seem to mean something, have some kind of power. So that was the theme, and I don't know whether you'd call it Platonic or what, but it's certainly something unusual. But then it would fit in with all these other things like the Cymatics and so on. So there's a subtle level of reality which impinges on what we observe, which of course is what David Bohm talked about.
Mm-hmm.
It's implicate order. I don't think he really got into the detail quite as much. So he did mention it's some sort of mysterious, like mathematics, which he said is a kind of magic, and I think it is. And so we just have to look into this mystery and see what there is.
Well, a number of physicists like David Bohm and Henry Stapp have argued that we need in some way to incorporate consciousness into our physical models. In fact, your paper on the physics of mind and thought was a part of a fest trip for Henry Stapp for his 90th birthday. But one of the things you point out is that even great physicists, like I think people would acknowledge Bohm is a great physicist, and Stapp, they seem to be marginalized as soon as they start talking about consciousness.
Yes, well, of course, Bohm probably wasn't the same level as people like Wigner.
Mm-hmm.
People are less inclined to take note of him. I guess people like Wigner were considered a bit strange for their mystical ideas. Wigner, I think, thought that consciousness it was a thing that reduced the wave packets.
Mm-hmm. Wigner and I believe John von Neumann also took that point of view, but I gather it's rather out of favor these days.
Yes, they like to do it all without this wave packet reduction, because that's not the ordinary equation. And but I think there seem to be serious flaws about that. Multiple universes, and then, well, I think the problem is what is it that causes us to see only one? You have to explain why we move into just one of them, and I don't think people explain that. They just sweep that problem under the carpet.
Mm-hmm. Well, you also draw on the work of Hofmeyr, the I guess biologist who talks about biosemiotics, and the notion of semiotic scaffolding, I think is quite significant. That I suppose every person, every viewer of this program might understand as we get older, we learn language. Once we learn language, we can learn more and more sophisticated concepts using that language. It sort of builds on itself. And that seems to be a property of biological systems in general. And you're suggesting that it's also probably a property of other physical systems like, well, water.
Yes, but it's really, I think, kind of mathematics, because one thing is that there are particular strategies for being good at or gaining a particular skill. And but I once had a student who did computer simulations on these grounds. He was actually testing a mathematical theory due to a Norwegian mathematician, Niels Bohr, and he wrote computer programs which put this idea in that you, by doing particular observations, you could develop particular skills, and then you got to one level, and then you started looking at something else, and that went on. So, in other words, it's not it's in the mathematics, and I guess the mathematics applies to the real system.
Mm-hmm. But I got the impression from your paper on the physics of mind and thought that you were really advocating, at least temporarily, that physicists begin to look at descriptive pictures of reality the way biologists do. And if they limit themselves just to mathematics, they're missing a great deal.
The thing that's particularly a no-no is the theory of everything, one equation for everything.
Mm-hmm.
I think pieces have their own mathematics, and then the bits of mathematics fit together in a kind of hierarchy. And as Karen Barrard actually wrote about that, she was a theoretical particle physicist, and she what's a book called Meeting the Universe Halfway, The Entanglement of Mind and Matter.
Mm-hmm.
She talks great lengths about things trying to get the idea over what happens at the human level, and she suggested, why is it just human observations that we put into quantum mechanics? It should be something much more general. In that case, let's see, matter feels and thinks, and all that is a statement she made.
I was under the impression that you really felt that, because you've used the word subtle several times in our discussion now, you're looking at subtle aspects of reality.
Have I talked about it? Karen Barrard has a picture which she calls a gentle reality. She wants to change how we look at reality, and she says, well, the thing which is reasonably objective is the phenomena, and then agencies that give rise to these phenomena. And then these agencies interact in special ways when they are cooperating. And he tries to get it to show that a lot of the mysteries of quantum mechanics fit into this picture. And he seems to have done this in independence of theories like semiotics.
Yeah.
Various habits, like there are all these different people get some consistent conclusions. So she talks about various habits, and then there's including language, and language is organizing things to help put them together. So she has a somewhat similar picture, but gets at it a different way.
Mm-hmm.
I think it's just a vast field, and you can look at different pieces of it and produce that theories of these pieces.
I mean, here we are having a conversation about some very abstract concepts, the nature of mind and the nature of reality itself. In order for us to even be having this discussion, there must be thousands of biological, biosemiotic processes going on in our facial muscles, in our nervous system, and they're all somehow coordinating with each other.
Yes, that's a mystery, and I don't know I think we may have to just accept it as a fact that it works like that. And in fact, we really need to apply that to our thoughts. We just automatically take it that our thoughts are making sense, but what does that mean? You get worried when you look into it. My thoughts presumably mean something, or they'd make no sense. And once I turned this into an aphorism, we think that we think clearly, but that's only because we don't think clearly. So, and we're so used to thinking that we don't wonder about it. And you then have to take the kind of pragmatic approach that we're just searching, and we have to accept that our thoughts about it mean something and build up in that way.
Mm-hmm. Well, while I have you with me, Brian, I wonder if you might say something about your interest in parapsychology. I know on one occasion, for example, it's been widely reported you were disinvited from a conference because one of the organizers learned that you had an interest in parapsychology, and in spite of all of your other scientific credentials, they felt that you were not welcome at their conference.
Yes, well, I heard this partly because one of the organizers was applying for a job, and he thought he'd better be careful. Yet the students might get a bad reputation. I don't know, this is a bit extreme. Anyway, I'll just go and get something. I don't know if I can.
Take your time. Go ahead.
Yes, well, my involvement began with a colleague, George Owen, who's, I think, a mathematical geneticist. In his spare time, he went along to places and looked to see if there was good evidence for the alleged poltergeists. Anyway, so he introduced me to parapsychology, and I at that time I was unaware that it was people were hostile to it. And anyway, I think it intrigued me was that there seemed to be parallels between parapsychology and quantum mechanics. And then he went to Toronto and he invited me to a conference on psychokinesis, actually, and I managed to retrieve this key, which is that showing up okay?
I can see the key, and it looks like there's a very slight, two bends in the key.
Yes. That was a parapsychologist there, Matthew Manning.
Yes.
A psychic. So he was demonstrating metal bending, and that is pretty difficult to bend with just your hands, and there were no great movements. He didn't appear even to be bending anything. So that was my introduction partly. So I rather stood on the sideline. I've focused on other things. I did write some. I've done a couple of papers on it, and been to some conferences, but that's all basically. Yeah.
I know on your website you make a point of putting up occasional papers that show the errors and the various criticisms offered by people who call themselves skeptics.
Yeah, yes. But it appears, though, that there's quite a proportion of scientists who believe that telepathy and so on are real, but they have to be careful not to talk about it.
Yeah. So
I don't know if you were there at, I think it was the centenary of the American Parapsychological Society held in Cambridge jointly with the Society for Psychical Research, and there Brian Pippard, who was my supervisor, PhD supervisor, he gave the after-dinner speech, and he revealed something he told me, that during the, let's see, is it First or Second World War, his brother was in action there, and his mother always seemed to know the situation he was in. Like once she said he's in a dangerous situation, but some days later she said, he's okay now. That turned out to be the truth. Mm-hmm. So he was fairly convinced it was real because of his mother seeming to be able to see what was happening there. He thought you couldn't experiment with it. And I think a lot of people seem to, just because you can't get perfect reproducibility and they don't realize you can look at the statistics.
Mm-hmm. So I would think, as a physicist, that this kind of data does resemble the sorts of weird things that are reported at the quantum physical level. In fact, I recall one physicist, Costa de Beauregard, many years ago, wrote a paper, I think it was published in Scientific American, and he said that if the parapsychologists hadn't already uncovered things like telepathy and psychokinesis, quantum physics should be predicting it.
Yes, the only thing is a theorem that it can't happen if you make certain assumptions about locality. So, in other words, you could put locality into quantum mechanics, and the usual theories are local, and then they show there's an influence, but you can't use it to send a signal.
Right.
That's the trouble. However, Fatini Palakari and I did write a paper where we showed that Bohm's hidden variable version of quantum mechanics, that there you might be able to get some psychic influences at a distance.
You've also, in your recent paper, quoted the work of Sutherland, physicist who suggests that backward causality can restore locality, but it might also allow for things like precognition.
I think what we have is final causation, which means if you know what the situation is heading towards, you can predict how it's going to get there.
Mm-hmm.
That's entirely classical, no backwards influence. The problem there is reconciling it with relativity, but that you then have to put in relativity by a different approach and say, well, this is an example of symmetry that appears, and where Sutherland wants everything to be consistent with relativity, whereas I think there is perhaps a fixed reference frame, a special one.
Mm-hmm.
And there I think you can have actions at a distance.
Mm-hmm. Well, to put it in more general terms, what I think you're getting at is that there's really a lot of disagreement amongst different schools of physicists as to how to interpret these basic theories that seem to work so well mathematically, but what they actually mean is still quite controversial.
They work well because physicists study matter,
mm-hmm.
and therefore they're avoiding the situations where mind would come into it and not be possible to fit it to the usual theory.
So, for someone such as yourself who is trying to find ways to introduce mind into physics, the problem, I guess, would seem to be that it could be disruptive to the entire field.
Yes, it would mean you would have to sort of start again. It would be the next step, just as you went from classical physics to quantum physics.
Mm-hmm. It created a certain amount of disruption back then.
Mm.
Yeah.
Yes, so I hope people will take it up. The paper's had quite a number of people even clicking to see the full text. So
mm-hmm.
I don't know who's actually looking at it, but it's doing quite well.
Yes, I happen to notice it's been read already over 700 times, I think, and hasn't yet even been published.
That's right. And more than 200 have clicked to get the full text.
Uh-huh. Well, Brian, it's been a pleasure talking with you. Thank you so much for taking the time to be with me.
Yeah, nice talking to you.
3 in the new Thinking Aloud dialogue series is UFOs and UAP, Are We Really Alone? Now available on Amazon.
You can now download a free PDF copy of issue 7 of the New Thinking Aloud magazine or order a beautiful printed copy.